In this video, I am going to be teaching you how to use Fleming's left-hand rule. What is Fleming's left-hand rule? It is a way of orienting three of your fingers, the first finger, the middle finger, and the thumb, to represent the relative directions of the magnetic field, the current, and the force when a long, straight, current-carrying conductor is placed perpendicularly to a magnetic field. Consider a magnetic field with magnetic flux density B, which points vertically upwards. Consider a horizontal rod with ends labeled M and N as shown, which is connected to a battery to form a closed circuit. Consequently, a current I flows, and in the rod, the current is directed from M to N. The rod experiences a force F directed perpendicular to both the current and the magnetic field. The direction of the current I, the direction of the magnetic field B, and the direction of the force F are mutually perpendicular to each other. These directions are related to each other by the Fleming left-hand rule. The rule states that if you orient your fingers as shown here, then we have the relative directions of the magnetic field, the current, and the force. The magnetic field B is in the direction pointed by the first finger. The current I is in the direction of the middle finger. And the direction of the force is in the direction pointed by the thumb. So in our case here, the magnetic field is vertically upwards. Therefore, the first finger should be pointing upwards. The current flows from M to N. Therefore, the middle finger should point from M to N. After correctly aligning these two fingers, the thumb points in the direction of the force as shown here. As we have seen here, the three directions lie along three perpendicular axes. What you are seeing here is a three-dimensional drawing, which can be difficult to draw on a flat sheet of paper. So how do we indicate the third direction on a flat sheet of paper? Let us have a flat sheet of paper, as shown here. Let us say I have a long, straight, current-carrying conductor on the flat sheet, and current is flowing from point M to point N. Since the long, straight, current-carrying conductor lies on the flat sheet, the current flowing in it also lies on the flat sheet. Now let us say I have a uniform magnetic field on the flat sheet that points from point X to point Y, perpendicular to the direction of the current. Using Fleming's left-hand rule, we see that our thumb points perpendicularly out to the flat sheet. This direction is referred to as perpendicularly out of the page. Therefore, the force on the long, straight, current-carrying conductor, with current flowing from M to N, due to the magnetic field pointing from X to Y, is directed perpendicularly out of the page. This direction, perpendicularly out of the page, is represented on a flat sheet of paper by a point. So, I can simply draw a point and label it as the force out of page as shown here.